So we're going to look at different types of data. So you've got categorical data, also known as string, and numerical, also known as scale. So starting off with categorical, you've got binary, which is male or female, yes or no. You've just got two distinct options. Nominal, which assigns something a code. So for example, A equals 0 or B equals 1. And ordinal, which is more of a scale. So no pain, moderate pain, or severe pain. Next, numerical data can either be discrete or continuous. So discrete data is a sequence of data, so 0, 1, 2, 3, 4, 5. However, continuous data can be any sort of numbers on a spectrum. So for example, the temperature, so 3.5, 3.8, 4.2 degrees Celsius. So next I'm going to run through the different types of statistical tests you can run through SPSS for different types of data. So first, if you've got two paired groups and you're comparing them on a numerical basis, use the paired t-test. If these results are skewed and non-parametric, the equivalent you would use is a Wilcoxon signed rank test. If you have two independent groups, this is where you use the independent t-test. The non-parametric equivalent for the independent t-test is the Mann-Whitney U-test. If you have more than two groups, so 3+, you'd use the ANOVA test. The non-parametric equivalent to this is the Cruxall-Wallis test. If you want to make multiple comparisons, so if you want to compare group A to group B and C, then group B to group A and C, for example, you'd use the Bonferini test. Finally, to assess a quality of variance, you would use Levine's test. So next, we're going to look at standard deviation. So to work out standard deviation, you first need to work out the mean. So for example, in this situation, you're going to add 8, 9, 12, 6, 4 and 20 together. Then you're going to divide by the number of points we have. So if you look at this, we've got 6 points. So it's 59 divided by 6 gives us the mean of these numbers, which is 9.83. Next, you're going to take each of those first numbers and minus the mean from them, and then square this result. So for example, you're going to do 8 minus 9.83 and square that. Now you're going to do this for the other 5 numbers. Now once you've done this calculation for the other 5, what you're going to do is you're going to get the mean of the new calculated numbers. So you're going to add up 3.35, 0.69, 4.71, 14.67, 33.99 and 103.43, which gives you 160.84. Now for this one, you're not going to divide by 6, you're going to divide by n minus 1. So that's basically 6 minus 1, the total number minus 1. So you're actually going to divide by 5 to get your mean for this. Now this works out to be 32.17. So you're going to take 32.17 and you're going to square root it. And this will give you 5.67, which is our standard deviation. So next we're going to work out the standard error. Now to work out the standard error, you need to divide the standard deviation by the square root of the number of patients or the number of points. So for this example, we use the standard deviation from above, which is 5.67. And I'm going to say we had 32 patients in this trial. So the calculation would be 5.67 divided by the square root of 32. And this gives you the answer of 1.002, which is our standard error. So next we're going to look at confidence intervals. For confidence intervals, you need to know some raw data. So in 90%, you need to know 1.645, and for 95% you need to know 1.96. Now these will come in handy later. So you also need to know the mean. So we'll use the mean from earlier, so 9.83. Now if we're going to work out the 90% confidence interval, we're going to take the value I mentioned earlier, the 1.645, and we're going to times it by the standard deviation. So going on the one we worked out earlier, that's 5.67. This makes 9.33. We're now going to divide 9.33 by the square root of the total number of patients, so the square root of 32. This gives us 1.65. We're going to minus and add 1.65 to the mean of 9.83. So this gives us our confidence intervals at 90% which are 11.48 and 8.18. So if we do the same thing again, but looking at a 95% confidence interval, we'll use the number 1.96. So we times 1.96 by 5.67, which is the standard deviation from earlier. This gives us 11.11, and if we divide that by the square root of 32, it leaves us 1.96. Now we take the mean from earlier, 9.83, and we add 1.96 and we subtract 1.96. This gives our 95% confidence interval of 11.79 and 7.87. So finally, we're going to talk about the interquartile range. So for this, you take a set of numbers and you order them numerically from smallest to largest to find the median. So in this case, you can see the median is 11. Now what you do is you draw brackets around the lower and upper portions that sit around the median. Then you find the median of each of these set of numbers. So as you can see, in the lower brackets the median is 6, and in the upper brackets the median is 16. This is the lower and upper quartiles. So what you do is you then minus the upper quartile, so 16, from the lower quartile, 6, and this gives you 10, which is your interquartile range of this data.